Hey guys, what's up? Welcome back to another video of the CSpreneur. Alright, so I'm super excited for this tutorial because I'm going to be teaching you how to program the sensors finally. So let's jump right back into where we were originally. So as you can see, we were at the stage where we had learned what all the move blocks did, and now we're going to be going into the sensor blocks. So I've already talked to you about the start block, correct? So the start block is basically how you start a program and how you're going to upload a program to the EV3. But there is also another option, by the way, for uploading the program, just so you know. Let's just throw some stuff onto here. Once the EV3 is connected, unfortunately my EV3 is powered off but once the EV3 is connected, actually you can just click this icon down here to actually load it onto the program, and you can also click this program to download and run on the EV3, which is super interesting. So it's just a 2-in-1 step if you have it plugged in already. So let's first go ahead and discuss what all of these blocks do. And what's really interesting is you can actually use these tooltips in the EV3 programming language. It's drag and drop, and it'll also tell you what all these do. So go ahead and consult with your partner if you're working in a group, or if you're just alone at home. That's fine as well. Just think about, just pause the video for a second and think about what this block does for a second. Okay, so I'm assuming that you've had a chance to work through it and pause the video. So you can see here that this says wait and this says seconds. So intuitively what I would think is that this block makes the program wait for a second. And if you thought that, you're exactly right, that's what it does. So you can see that there's time and there's all of this stuff. Now I'm going to be teaching you what we need to use for today's challenge. So you can see here that we have the color sensor, and we can compare the color, the reflected light ambiency, and the ambient light intensity. So what we're going to be doing, we're going to always be using reflected light intensity. And so again, what that is, that's detecting how much light is being reflected back into the sensor. So we can use a compare essentially equation over here. So over here what we're getting the value of the color sensor, and over here we're comparing that to a certain threshold value. And so what the threshold value says, for the example this block, we're going to wait until this condition is fulfilled essentially. So again, we're going to wait until the value that's coming out of the color sensor is less than 50. So go ahead and consult with your partner what you would think that would, what type of situation do you think the color sensor would be in that case, based on what you already know. So if you thought that the color sensor would essentially be in a condition where it's reading a black light or a black line or black paint, then you're exactly right, because the black is going to be absorbing a lot of that light, whereas the white, just a white pad or just a white cloth, is going to be reflecting back a lot of that light. So if the color sensor is on black, then you can actually automatically detect that using this method. So let me go ahead and power on my EV3 and let me show you how we can write a simple program to just use this basic logic. Moving on, while this is just powering on, we're also going to be using the infrared sensor, or for those of you following along in an NXT 2.0, perhaps an ultrasonic sensor. So we can compare again the proximity. Don't even worry about the beacon heading, beacon proximity, and remote. We'll take care of that later, much later, maybe not even in this tutorial series. So again, we're just going to be learning the basics. So we'll also be covering change at a later time, just not in this tutorial series, as this is only covering the basics. So again, the EV3 is now powered on, and what you can detect is the distance. So I think this would be more easier to explain with the infrared sensor. So let's actually compare the proximity of the value that I'm getting from the infrared sensor. So we're going to wait until we get a certain value of from the infrared sensor, then we're going to compare that to, so we're going to see if it's less than 50. And so what is the value that we see here on this log? currently what I'm receiving is 78. So if we're going to detect, let's say, an obstacle of some sorts, like some of these paper towel dispensers do, remote paper towel dispensers do, then we're going to be detecting someone putting their hand in front. And what do we see here? We see a value of somewhere less than 50, definitely less than 50. We're well below that. So what we can say is, so we're going to wait until the value is under 50, and if you guys have some sort of a motor or a move block of some sorts, then you guys can be using that. But what I'm going to do, because I don't have a motor connected, I'm just going to make the program just make the brick beep. So what we see here, we also see a port for the sensor, and notice how I told you last time that we also have to make sure that the port matches where the sensor or motor is plugged into the EV3 brick. So what I'm going to be checking is if the ultrasonic sensor is connected to port 4, and guess what, it's not, it's connected to port 2, which is exactly right. That's what we have over here. So let's go ahead and download and run. So again, you can see that tooltip. We're going to download and run. And so what we see here, actually, if you notice, or let me just detect this real quick. So what you can see here, I'm just going to zoom in that in post-production, but you can see that that block right there is executing at that given time, given by those stripes that are moving. Now what I'm going to do, I'm going to place my hand and watch very carefully where the stripes move. Ready? And so the stripes stop. It's weird that it didn't beep, actually. Let me just...
Black.
Okay, so there we go. So we'll make it say black every single time. Okay, ready? So again, it's going to execute. And so it said the word black when I put my hand in front. So again, we can just try something else. Expressions. You can cheer if someone puts their hand in front of a paper towel dispenser, I guess. So again, I'm going to be holding this, watch what is executing, and I'm going to put my hand in front, and people cheer. And so that's just a super simple example of a program using basic logic. Now, I'm going to cut the tutorial here, and actually, you know what, let's go ahead and do one more example with the color sensor so that you're well prepared and well on your way for today's challenge. So notice how I'm getting a reflected light of 0 because I'm not even reflecting it off of anything. Whereas if I put it on my desk here, I'm getting a reflected light of 5. Whereas if I put it under my white Apple mouse here, I'm getting a higher reflected light ambiency, even closer to 97. So what I'm going to be detecting is a change in, or perhaps even when I'm going to move my my color sensor to my mouse. So let's go ahead and do that. So let's change the sensor. What sensor are we going to use? We're obviously going to use the color sensor here. So we're going to compare the color. And so, oh my bad, sorry. No, we're not going to compare the color. We're going to compare the reflected light intensity. And so we're going to be detecting if an object is white, which means that it's going to be brighter than 50. And so we're going to be detecting if the value is greater than 50. Now also notice, just really quickly, I want to mention that there's also greater than or equal to and greater less than or equal to, and also even equal. Now we're typically not even going to use equal ever. I can't really think of a scenario where the color sensor would actually really be that precise to detect that. We're going to typically want a range of values. So let's go ahead and say if the value of the color sensor is greater than or equal to 50, we're going to, let's see, what do we have here? Location.
Fantastic.
We're going to say fantastic in a robotic voice. How about that? So let's go ahead and download and run. Now notice on the log is still continuously updating, so just keep watching that. So I'm going to put my hand, but since that's not as white as the mouse, we're not going to be getting a fantastic. And notice,
fantastic.
So now we've brought it so close to the mouse that enough light is being reflected back to the sensor that the robot can now detect and say fantastic. So I'm going to cut the tutorial here, and we're going to come back next time and actually discuss what some of these other logic blocks do. Don't worry, they're super simple, and yeah, hope to see you next time.